All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing a Python study stream. Yeah, I guess we could call it that. Yeah, it's a Python study stream. More specifically, we're going to be studying how to do async stuff in Python using the asyncio library. Is that what it's called? Let me just confirm. I think it's asyncio. Yeah, using the asyncio library, and let's hope that we don't have any connection issues today. Because just my luck, yesterday when I was finally doing a vocal stream after probably, I don't know, 10 days of not doing a vocal stream, when I finally did a vocal stream, like maybe 20 minutes or 30 minutes into it, my internet connection just went out. Give me a second. Yeah. Like, I don't know, 30 minutes into it, my internet connection just went out because I hadn't paid the bill. So, yeah, that was unfortunate timing. Hopefully, everything everything is fine today. So, okay, let me explain how I got to this point where I need to. I mean, I've been wanting to learn. I've been wanting to learn uh, about the asyncio library for a while now, and I've kind of been doing it like on and off. Like I'll come every now and then, look at it, you know, read a little bit about it, and then just get distracted with something else. So eventually I was going to, get to this point anyways. And we are there now. Well, we are here now, which is great. But like how I got to this point this time is the other day I got this idea, which I've had this idea as well for a while, but like the other day I decided to finally act upon it, finally, flesh out that idea, which is basically creating a simple Python GUI in which I can display text, and it's going to have a green screen. So then I can basically overlay that text onto my screen. So the whole idea was to create a sort of closed captions thing. It's going to be a mixture of things. It's going to be like closed captions and TTS, and I don't know if at some point I want to add speech to text to it. Then maybe I'll. I mean, okay, actually, in terms of being closed caption, it's for now, for the time being, what functionality I plan to build into it is text to speech. So I'm going to send in messages from another computer because that's where I'll be typing out the messages. I'll send messages in from another computer over the network to this computer where the app is going to receive the message and then display that text that's in the message. It'll display that text on the screen. Additionally, so that's going to be mute speaking, let's say. So that's initially how I got the idea, because I wanted to have something where I can speak even during my mute streams. So I wanted to start with just the text, and this idea, it works out well for me. At a later time, I want to add TTS support to the I still don't know what I want to call this app. I'll come up with a name at some point. But yeah, I want to add TTS support as well, because I mean, we're already receiving the text over the network, right? We're already getting the text, and the text is being displayed on the screen already. So additionally, I can run that text through some kind of TTS model and play the audio for that. So that way I'll have text on the screen, and I'll also have, the text being read out loud. So that can be useful for my mute streams. And once I've set that thing up, I could also add in the functionality at a later time for a speech to text model, which will which I'll use during my vocal streams, my talking streams. And basically I will capture my mic audio and send those samples into a speech to text model, and then that's going to spit out text which I will then display on the screen. So why am I looking at async IO? Because I need to do some networking stuff, and the networking, more specifically the sockets related stuff, is a lot of it is a lot of those functions, they're blocking functions or blocking methods, meaning they're going to block the entire thread until they finish executing. So I can't use those if I'm trying to, like, if networking or socket stuff was literally the only thing that the app was doing, then it would be fine if it was blocking. But in this case, there's going to be a lot more going on there. For one thing, there's a GUI that's running, right? I'm going to be using OpenCV to do the GUI because I don't need anything very complex. I don't even need anything that's good looking. I need very basic GUI. Also, speaking of GUI, I want to test this out right now because I tested this out off stream and it seemed to work off stream. But like in the past, I've had this issue where the thing doesn't work on stream. What I'm talking about is when I run, uh, which one should I run? I think I can run it from here. Maybe what was I doing over here? Give it a second. I haven't touched this in a bit, so it's oh yeah, okay. So this was where I was doing the GUI stuff. So basically, this code, it creates a window, and then it resizes that window to a specific height and width that I've set. Then it creates an image and fills that image with a green color. And then I'm drawing a circle on there just for the sake of, I needed some stuff to draw onto the image, so I just chose a circle. And then we enter this while loop where we are constantly reading the key. We are reading for, is that right to say? We are trying to read the key presses, so we are waiting for a key press, and depending on the key press, if it's one of these keys, then we do something here. And then we also refill the image with green color and draw the circle again, and then also put text onto it. And then finally we draw, oh, that's what's missing here. Finally, we draw that image onto the screen. So in this case, I think it was I am show. I don't remember. So this runs in a loop where each time it's drawing a green screen, and then it's drawing the circle, and then it's drawing the text. And the text, I set it over here. I've created a text buffer where depending on the key that's pressed, it's going to change the text, and then it's going to draw that text. So that's what's going on in this program. In the past, an issue that I've had is I was not able to capture the window that pops up, the window that's created through OpenCV. I had an issue with it, and I wasn't able to figure out why exactly that was. But I think there might have been something that I missed there, because like, okay, OBS has this thing where if I'm trying to do, and this is, I've noticed this with window capture. I don't know if this is the case with game capture as well. I haven't tried it out with game capture, but I've definitely noticed this behavior with window capture. Let me show you. Let me switch to desktop scene temporarily. just so I can show you guys. All right, so let's say I am looking at this scene. This is my current scene. Or, well, I mean, right now I'm in desktop capture, but like I'm going to be transitioning to this screen, this scene. Yeah, I'm going to be transitioning to this scene because this is the scene that you guys were seeing earlier. And in this scene, I have a couple of sources. Now, in sources, I have window capture. I have a couple of window captures, and here I'm able to decide like which window I want to pick. What happens is sometimes windows don't appear over here. When that happens, I need to make sure that that window is maximized. I first maximize that window, and then I come back into OBS, and then I have to click away from whatever window capture source I was clicking on initially, and then click back on that window capture source, and then when I open it up, then I'll see the item in the list. This is a technique that like I've had to use. I've been doing this for years. It's just how it is. I don't know why that's the case, but like that's just the way it works. So it's not a big inconvenience. It's just something that I have to remember to do, and I have to do at this point in time. I do it pretty much every stream because each time I start up a stream, let me transition back. Each time I start up a stream, as you can see, I have at the very least I have two window captures going on, if not three. So I have to do these steps for each of these captures, which it's not tedious at all. It's just one of those things where I have to maximize the window and then, add the source and all of that stuff. Not add the source, select the source and all of that stuff. Okay, so the other day when I tried capturing the window, the OpenCV window, the window that gets created when my OpenCV code is running. I tried capturing that window and it worked, which was great. So I'm going to try that out again today. And if it works, that means I can then use this very simple OpenCV GUI to create my closed captions slash TTS slash STT app. At this point, I'm considering just for shits and giggles, I might just call this app Yap, because basically, I'm. It has a lot to do with me yapping. So when I'm mute, it's gonna help me yap. When I'm not mute and I'm yapping, it's still gonna display the closed captions. So it's still gonna help me yap. And oh wait, no, was I talking about TTS? No, there I was talking about STT. And then, of course, yeah, there's TTS, which will also help me yap when I'm mute. So let me say that again. It's going to help me yap in the form of just text. It's also going to help me yap in the form of audio. And yeah, that's it. There's going to be subtitles, which is the closed captions. And then there's going to be subtitles plus audio. So that's going to be two modes. One is going to be text only, and another is going to be text plus audio. And then the third mode is going to be only text, but that text is going to be generated through an AI model. It's going to be generated through a speech to text model. In the first case, the text that I'm talking about, that text is going to be typed in on another machine and it's going to be sent over the network. Okay, so let me test this out real quick. Let me just hold on. Okay, so I'm going to save this and then run this script. This will bring up the window, and then I want to capture that window. So give it a second. You guys are not going to see the thing when it pops up, but once it does pop up, then I have to selected in my window capture. Something else that I want to test out is because the window has a name, like we are able to name the windows, right? Because the window has a name and window capture, it kind of takes the name into account. Actually, I think it really strongly considers the name. I wonder if, let's say I open up the window. Okay, hold on. Let me do one thing at a time. I'll come back to that thought in a bit. Uh, what was I doing? Yes, I was trying to open this up. Okay, so we're gonna open this up. Okay, I am able to select this and I'm able to expand it. Oh, hold up. Okay, this is behind. So let's bring this up here so it's in front. I think I should also reset the transform. Where is that? Reset transform. There it is. Okay, so I'm going to transition. So this is our window. Great, awesome, right? In this window, I've set up the text thing where, it says this is a sentence. When I hit one key and when I hit another key, it's going to change that sentence to this is another sentence. Great. So at some point in time, what I want to do is, you know what, I can do this live. So I'm going to add a filter to this. Mainly it's just a chroma key filter. It's mainly the green screen thing. Right? So we can add that and we are good to go. There it is. Okay, cool. Awesome. So now what I can do, okay, so I'm gonna take off this filter for now, temporarily. So now something that I want to test is, all right, so what I'm capturing here, the window that I'm capturing is a Python window with the name, or well, a python.exe window with the name win01. That's just a name that I've given for the window here in the code. Let me show you. Yeah, that's just the name that I've given to the window. And so that's the name that the window has, and that's also the name that OBS is reading, right? Which is great. So what I want to test out now is, let's say I quit this program. So the window is gone now, right? Because the window is closed, so that window is not being captured anymore. Okay. Now what I want to see is if I run the script again and the same window is spawned again, will OBS automatically start capturing the window again just because the name is the same? Or am I going to have to capture it again? Let's test this out. Hell yeah, dude. It's capturing. Okay, awesome. Great. So we don't need to worry about having to, I mean, it would have been a minor inconvenience anyways, even if I had to, make the thing start capturing again. It would have just been a minor inconvenience because it's not like I plan on closing the window every single time. The whole idea is I'll start the app and then the app is just going to continue running throughout the duration of the stream. So as long as I'm streaming, the app is going to continue running. Okay, now we can change the color. Let's change the color of Let's change the color of the text. And I also want to add, I think I'll need to add like a black box behind the text. So, okay, I'm going to change the color of the text to, wait, where was the color specified? I think it was here. Okay, so 255, 255, 255, that's white. And if I green screen the text now, or if I green screen the window now, then we should be seeing, hold on, let me enable this. Okay, done. Great. Awesome. So this is our window, right? I can increase the size of the window, and actually I can make it like, okay, I'll see what size I need to make the window. I guess the window should be full sized anyways, right? I can make it the full size of the screen and then just green screen the entire thing, and I can decide where the various text elements go. I just realized that the changes that I'm making are not showing up because I haven't transitioned yet. So, okay, now you guys should be able to see it. And this is the text. What I want to do is I want to add a black box behind the text, or any kind of like dark, any kind of opaque background. It doesn't have to be black. Any kind of opaque background that'll help the text stand out, and that'll also not occlude the text. Um, Hold on. Well, I don't know if occlude is the right word here. Something that'll not blend in with the text. That's a better way to put it. I want a background that's not gonna blend in with the text. So initially, I was kind of concerned about whether I should use OpenCV's GUI for doing what I'm trying to do, because like I was concerned that is is the text rendering gonna be slow or something? Should I work on like a custom plugin in OBS directly? But then I was like, you know what? Let's try it out. Let's test it out and see if the problem arises. Because as it stands right now, it seems like the basic functionality that OpenCV does provide in terms of GUI, that is kind of, it's solving my problem. It's doing what I'm trying to do. It's helping me accomplish the goal that I'm trying to accomplish. It's not like I'm doing any, custom text animation and stuff like that. So I don't think I need to worry about that too much. At most, in terms of animation, I'm gonna have to worry about how the words show up on the screen, or how many of the words show up on the screen. Because I need to, how do I put this? I need to present the text in such a way that it can be read by the viewers, right? It should be there for enough time that the user is able to read it, the viewer is able to read it. It shouldn't disappear very quickly. However, I think the situation is going to be a little bit different once I plug in a TTS model, because then it's going to be so. Okay, I'd mentioned earlier that the program is going to work in three modes, right? The first mode that I'm working on, the first mode that's the easiest to accomplish right now, and the first mode which is also what kind of started me working on this program. The first mode is just text mode. In this mode, I'm going to be sending messages from another computer into this computer. So basically, this program is going to be receiving messages from another machine across the network. And the reason I'm doing that is because it's much easier for me to just pick up, because I have a couple of machines around me right now, and one of those machines is where I'm going to be typing the messages from. So there's going to be another program running on that machine, or well, another Python script, similar Python script, where I will be where I'll be typing the message in. And as soon as I hit enter, it's going to send the message over to this machine where the message will be displayed. So that way, I don't need to switch between windows to type in my mute messages. I can just pick up the other keyboard and type into that keyboard, and the messages will appear on the screen. Or well, I can pick up another keyboard, I can type into that keyboard, and those messages will be sent over the network to this machine, where they will then be printed onto the screen in this manner, the way that you're seeing this. Of course, it's not going to be in the center of the screen. I still have to decide on proper placement and all of that stuff. All of that can be decided later on. All of that can be changed. None of it is set in stone. So that those minor details can be looked into later on. For now, something that I wanted to do is, and that's actually, holy shit, we are 25 minutes into the stream and all I've been doing is yapping, which I mean, I kind of like that, dude. I kind of like that. I kind of like the fact that I'll start up the stream and I'll just start talking. I like that. Okay. Um what was I saying? Yeah, so that's what we were planning on doing today anyways. We were planning on learning about async IO. So, okay, the whole idea with async IO is that it allows you to write asynchronous code so that you're not writing code that's going to block your main thread, which is great, right? Um, async IO. Hold on, let me close this. You know what? Since this is now capturing the window, I think I'll leave this window capture visible. So each time I run the thing, you guys can also see the thing working, which I'm super happy about the fact that now I'm able to capture the OpenCV window as well. Previously, somehow it didn't occur to me that this might be the problem. I've tried in the past because I've done OpenCV stuff in the past where I was doing various things that either directly or indirectly involved OpenCV. And because OpenCV was involved, so I had the option to use their GUI, which I did, right? But then the problem was that I wasn't able to get it to be captured by OBS. And I wasn't sure what the reason was. And then a couple of days back, or maybe a week back or something, I don't know. It was fairly recent. I got the I got this thought. I was like, dude, I have to do these things, these extra few steps when I'm trying to capture other windows before I start my stream, right? So what if that's the same issue that we are having here with the OpenCV windows? And so I tried it out, and that turned out to be the case. It turned out to be the case that I just had to get the name to show up in the list, which, not OpenCV, OBS has like certain things that I have to do where certain things I have to do in order to get the name to show up in the list. So I did that, and the name showed up, and well, now we are able to capture OBS. No, we are able to capture OpenCV windows, which is great. Awesome. What was I doing? Oh yeah, we were gonna start reading the async IO thing. So specifically, I want to focus on. Okay. So here's the thing, right? Two things I wanted to focus on with async IO were coroutines, which is regular async functions, and well, I mean, they're not regular async functions, but it's basically, well, yeah, I mean, technically, yeah, they're regular async functions. Like the whole idea with coroutines is that you can start them and then you can pause them at some point and then resume them and then pause again and then resume again before you finally finish, right? It's not like a regular function where once the function starts, you can't stop it. You have to finish the entire function before you can do anything else. So one of the things that I want to do with async IO is the coroutines. And the other thing is network IO and IPC. More specifically, network IO in this case, because I'm doing it like, across the network. However, when I looked into it, out of the box, or well, let me say at a very high level, what's supported is TCP. not UDP. UDP is supported. There is support for UDP, but you have to do a few slightly lower level things for that, which means I'm going to have to dig a little deeper into this. And I found the section that I might need to read, but what that tells me is that, hey, Sarah, welcome to the stream. Hello, hello. It has been a while. I'm okay. I'm happy to be doing a talking stream again. Um, and I'm happy to be doing my study streams. How are you doing? It has been a while. What was I saying? What was I saying? Yeah, so I was actually okay, real quick, before anything else, there's gonna be an ad playing in like 30 seconds. So I'm gonna hit the ad button right now, and I'll see you guys in 30 seconds. I'll take a little hydration break in the meantime. So yeah, I'll start an ad right now, and I'll see you guys in 30 seconds. All right, welcome back. I'm currently sweating because it's kind of hot in my living room. So came back to my room to finally cool off for some. Yo, it is crazy. That sucks. Like it sucks that you're dealing with the heat. It is, dude. Summer is crazy. Each year, it's becoming even more crazier. Like, I cannot imagine being without AC, and there are people who have to be without AC. Like, that's the crazy part. It is getting insanely hot outside. I don't know what your situation is, uh why you don't have the AC turned on, but like yeah, it's crazy. The heat is insane. Okay, so back to what I was saying. Um wait, I made something new today. I made something new today that I'm proud of. I'll send it. Hell yeah. Yeah, I'll take a look after the stream. But good on you. Good on you. Hell yeah. What was I saying? Yes. So, what I wanted to do is I wanted to do the high level stuff with async IO before diving too deep into, or before even touching any of the low level stuff. I didn't want to touch any of the low level stuff unless I had to, because I don't know. I feel like it's gonna save me some time if I don't go into the low level stuff. But it seems like I kind of need to for certain things. Because like okay, out of the box, or well, out of the box, the high level APIs, um, they mainly support TCP. They don't support UDP. There is support for UDP, but like in order to do, you have to let's just say you have to create the high level API. They have support on a lower level for doing UDP stuff. So I'm wondering if, because usually I like to do UDP, mostly because it's a little simpler, and I'm okay with using a connectionless protocol, even though there's how do I say this? I'm okay with using UDP, even though there are certain chances. There are certain risks of, maybe data not arriving or data being broken or something like that. There are like rare chances of that. I I still like UDP because it's a little simpler. You don't have to like establish this connection. You can just start sending stuff, or you don't have to establish and maintain a connection. You can just send from one end and receive on the other end. You basically throw the message at the receiver, and if it sticks, it sticks. Usually, it sticks. So, I mean, I kind of like working with UDP, and I wanted to do that here, but it seems like out of the box, the high level APIs don't support, or rather, there is no high level API for async UDP stuff. There is support for it in the low level API, but you would then have to build up on that, right? You would have to build upon that. Yeah, you would have to build upon that. And I haven't looked into the low level stuff yet. I was trying to avoid the low level stuff unless I really needed to, because usually what happens is I'll start digging too deep into the thing, and I'm gonna lose a lot of time if if I keep digging into it. I do want to learn more and more about async IO, because there's a bunch of other use cases I have for async IO, not just this one use case. So learning more about the low level stuff is going to be beneficial for me, and I kind of do also want to learn about the low level stuff, but I just don't want to do it right now unless I really need to, because there's a bunch of other things that I also need to spend time learning. And time that I'm spending learning here, I'm taking time, that is time that I'm taking away from learning other stuff. Currently, the other stuff, some of the other stuff is Seaborn. Seaborn is this library. We're going to carry on learning about this as well, because I have a use case for this already, like an actual use case for a project that I've been working on, where I'm helping a family member out with some, let's say some stats stuff for their business. So initially, I was using Matplotlib for it, and Matplotlib is great. Matplotlib is it's an incredibly powerful graphing and plotting library, a data visualization library. You can do a lot with it. It is incredibly customizable, or it is incredibly extensible, let's say. You can customize your graphs and plots and stuff to a crazy amount in Matplotlib. But the issue is, in order to do customizations in Matplotlib, there's quite a bit of, how do I say this? You have to learn about all the bells and whistles. You have to learn about all the various parts of of the graph, of the plot, the various parts that come together to make that plot, that graph. You have to learn about those various parts just so that you can customize them. The API for customizing the the plots is not that great. So you have to learn quite a bit about the framework in order to be able to do, very deep customizations. And that's a bit of a hassle. Let's say it's a bit of an inconvenience. So something that I want to do is, I want to learn Seaborn. Seaborn, the whole idea with Seaborn, in fact, Seaborn was, I believe it was initially made with that in mind. Seaborn is built on top of Matplotlib, and it provides you with high level functions to be able to customize your plots in various different ways. Of course, if you do want incredibly complex customizations, you're probably still going to need to go down to the Matplotlib level, but there's quite a bit that you can accomplish even with their own API, with the Seaborn API. So that's why I decided to learn Seaborn. Besides, I've learned Matplotlib. I've spent the time learning Matplotlib, and that's why I know about how complex it can be to do, well, complex customizations in Matplotlib. So that's why now I want to give Seaborn a try, and that project that I've been working on for someone else, I I kind of want to transition from using matplotlib to using Seaborn instead. So I want to get more comfortable with the Seaborn library before I start doing that. So I think that's going to be part of some of the future mute streams. I'm trying my best to do more and more streams, whether they're mute streams or talking streams. I'm trying my best to do more and more of these streams. Yesterday, I believe I did a mute stream earlier. I think so. I think I did a mute stream earlier in the day, and then a couple hours later, when I wanted to do another stream, that's when my internet cut out, so I wasn't able to, I wasn't able to carry on. Hold on, did the music stop? I think the music stopped. Yeah. Okay. Uh, what was I saying? Yeah, I was talking about how like the internet cut out and I wasn't able to, I wasn't able to do the talking stream. I was like maybe 30 minutes into the talking stream and the internet just cut out. Fortunately, I'm able to stream today, which I'm happy about. Um, Today we are going to be doing, holy shit, we are like 40 minutes into the stream. Okay, so we are going to be taking a look at async IO. Uh, Mainly, I want to try and stick with, coroutines and network IO for now. I'm not going to be touching sub processes or queues or uh, whatever the synchronized thing is. I do want to look into event loops and transports because that has to do with networking specifically. So I kind of want to look into that. But that's going to be at a later time. For now, I think what I'm going to do is if give me a second. Yeah, what I you sent it. Nice. I'll take a look at it after the stream. Um, I'll try to remember to take a look at it after the stream. I should put it that way because once I finish the stream, I'm I usually have to do like a couple of other things, post stream things, and I just then relax and I don't remember to look at Discord. I'll take a look. I'll take a look at it at some point. Um, but yeah, thanks for sending it. So, what was I saying? Yes, we're gonna start with the high level stuff, and then at a later time, maybe I'll look into uh, event loops and transports. Hopefully, if things are not too complicated, then because I don't mind things being complicated, right? The issue is the more complicated it is, the more time I have to spend. Um, the more time I have to spend learning it, and the more time I spend learning something, that is time I'm taking away from learning something else that I have to be learning currently. And currently, I do have other stuff that I need to be learning. That's kind of why I'm kind of budgeting my time with between this and that and then something else because I'm currently doing async IO. I also need to be doing Seaborn. I need to be learning about Seaborn. I also need to get back to learning about stats and linear regression so that we can then get back to doing data science stuff like I was doing on Kaggle. So there's a bunch of shit that I need to be doing, which is why I need to be budgeting my time in this way. Anyways, let's get into this. So we're going to start by reading this. So async IO is a library to write concurrent code using the async await syntax. Async IO is used as a foundation for multiple Python asynchronous frameworks that provide high performance network and web servers. High performance network and web servers, database connection libraries, distributed task queues, etc. Async IO is often a perfect fit for IO bound tasks. No, IO bound and high level structured network code. Okay, awesome. Great. So the first thing we're going to look into is coroutines, which is here. I don't think I should have to go over the entire thing, should I? Because, okay, this is talking about tasks specifically. I want to go into coroutines. I wanna go into just coroutines for now. I don't want to go into like, wait, there's awaitables as well, right? Okay, so I wanna just look at coroutines and awaitables. Um, I don't know if I want to look into creating tasks. Okay, you know what? Let's take a look. Well, okay, this is basically covering a bunch of the API. No, no. Okay, it's explaining some stuff as well. Okay, so we'll start with this. Um, coroutines. Coroutines. Wow, I'm getting stuck on the word coroutines. Coroutines declared with the async slash with the async await syntax is the preferred way of writing async IO applications. For example, the following snippet of code prints hello, waits for 1 second, and then prints world. All right, so we're gonna try this very basic thing. Uh, what is the code? Import async IO. So we're gonna. I don't know how well that works with cells or well with the Jupyter notebook. Okay, so let's do import async IO, and then we have async. We create this thing and then print and then sleep and then print. All right, so we'll define this function first. This is a async function. We print hello. Then we do, what is it? Async IO. No, it's await. Okay, so we're supposed to await. I'm guessing that's an awaitable. That's where awaitables comes in, doesn't it? That's the next thing over here. We say that an object is awaitable. No, we say that an object is an awaitable object if it can be used in an await expression. Many async IO APIs are designed to accept awaitables. There are three main types of awaitable objects: coroutines, tasks, and futures. Okay, this is coroutines. Then we have tasks. Tasks are used to schedule coroutines concurrently. When a coroutine is wrapped into a task with functions like async io.create task, the coroutine is automatically scheduled to run soon. Futures. A future is a special low-level awaitable object that represents an eventual result of the asynchronous operation. Okay. When a future object is awaited, it means that the coroutine will wait until the future is resolved in some other place. Future objects in async IO are needed to allow callback based code to be used with async await. Normally, there is no need to create future objects at the application level code. Future objects sometimes exposed by library. Future objects sometimes exposed by libraries and some async IO APIs can be awaited. Okay. All right. So once I get into low level stuff, then I can look into this. Okay. So that is where we get into creating tasks. I could look into tasks as well. For the time being, I kind of want to just stick with the simpler stuff. Let me understand the simpler stuff, then go into the deeper stuff. And I feel like I should finish this entire section before I move on to the streams, because there seem to be a bunch of different very basic async IO not messages, methods and functions and stuff that uh, I feel like I should know about before I go on to do slightly more complex things. Yeah, yeah. I think I'll do that. I think I'll finish this page. This is a fairly long page to finish, though. I don't know how much of this I'm going to be. Okay, so there's a couple of things here, right? So we have timeouts, then we have waiting primitives. I don't think I'm going to be looking into running in threads. Scheduling from other threads, not going to look into that either because I'm not doing threading stuff. What is introspection? Return the currently running task and so on, so on, so. Okay, all right. Um, this is mainly methods. Task object. Tasks are used to run coroutines in event loops. If a coroutine awaits on a future, the task suspends the execution of the coroutine and waits for the completion of the future. When the future is done, the execution of the wrapped coroutine resumes. Okay, all right. Just a second, guys. Okay, all right. So, yes, I was doing this, the simpler stuff. Let's let's get a hang of the simpler stuff first. Then I can go into the more complex stuff. So async io.sleep. So I'm guessing because this returns a coroutine, that is why this is awaitable. Like, is that how I know that this method is awaitable? Because it doesn't mention that it's awaitable. Okay, coroutine that completes after a given time in seconds. So we're gonna do 1 second. Hello world. Okay, cool, great. So once that is done, what was the next thing? We are just calling run. Okay, async io dot run main. How are we calling this? Do we need the parentheses? Okay, we need the parentheses. All right, so we're gonna run this. So let's see what happens. Oh, there's an error. Async io.run cannot be called from a running event loop. You know what? What if I just call the method directly? Because I had a doubt that the way that Jupyter Notebooks is running, it might kind of interfere with the way this is running. There was a way around that. I don't remember exactly what it was. Let me just Google that real quick. There was a way around that whole thing. Let me just do something on another system. My God, do I need to change the battery on this again? I recently changed it, didn't I? Or maybe this was the one that I didn't change. No, this was the one that I did change, and the thing seems to be dying already. Okay, anyways, async io dot run Jupyter Notebook. How do I run Python async IO code in Jupyter in a Jupyter Notebook? All right, let's take a look at the answer. You must now just do this. Okay, so I have to await main. So because this is an async method, this can now be awaited, and so I'm able to do that. Okay, that's cool. Hell yeah, dude. Okay. Yeah, so I had a doubt that there might be a slight change I need to make. Like there might be an issue that I'm gonna run into where I'm gonna have to make a change in the code just so it works in Jupyter with Jupyter notebooks, and this was the change. So this is all I need to keep in mind. So if I'm running this from within a Python script directly, then I have to do asyncio.run. Though I need to see how I would go about just using regular await syntax. Because, like, why do I need to do async io dot run main so and so instead of, just doing await? I should test this out. I should test this out in like a regular script instead of a notebook. Anyways, for now, I get it. Note that simply calling a coroutine will not schedule it to be executed. Yeah, that's what happened here. Yeah, that's interesting. It's if I'm doing it in this way, it seems to be printing the function itself, like the function object. So for example, I don't know if I'm gonna do this right, but let's say something like this. Okay, and then I try to print out just test. Give it a second. Oh wait, not test. Test O1. Actually, hold on. Okay, so this is supposed to be throwing some kind of error for some reason right now. Um, yeah, there it is. Well, I mean, I was trying to show this, but like I wasn't expecting this exactly. But yeah, would it have been, what if I did this? That's what I was trying to show. Function test at so and so. If you try to just print the function the function object itself, then that's what you get. Or I don't know if it would be called an object, because like a lot of things in Python are considered objects, which is why like you're able to do a bunch of different things with them. I I don't know if I made a whole lot of sense there, but like look into it. A lot of things in Python are objects, and so stuff that like you might not think would be possible because it's not possible to do it in other languages, you come into Python and like it's possible to do it. Actually, that's not entirely accurate. Stuff that might not be straightforward to do in other languages. It's not that it's not possible to do it. Though, I mean, it could also be not possible to do it. Okay, I'm going to stop talking about this. Let's move on to the next part of this. To actually run a coroutine, async IO provides the following mechanisms. The async IO.run function to run the top level entry point main function, see the above example, and the other one is awaiting on a coroutine. The following snippet of code will print hello after waiting for 1 second and then print world after waiting for 2 seconds. All right, so here we have a main, which is an async function, and then we also have a say after, which is also an async function. So this is interesting. Both the functions here are async. I'm guessing because one of them has to be called as an async function, and the other one, in the other one, we are actually, awaiting. Uh, though actually, no, no, hold on. The reason why the other one also has to be an await, has to be an async function is because we are awaiting that function, or we are awaiting that coroutine in the main function. I think that's also why it's an async function. Because I was going to say that it's probably an async function because we are awaiting, we are doing an await thing in here. Actually, no, that might be true. That might be true. Because from what I remember, the whole idea is like you can await things within an async function. And what happens when you await it? I think when you await it is when it actually gives control back to, wherever it was calling from. I think that's how it works, right? I need to find an example, maybe like a file IO example where I'm doing some kind of file IO operation, and in the meantime, I have to have the rest of the thread available to me. Yeah, one example I can think of is like I don't know how well the example is going to work out, but like just on paper, this is what I have right now. I could create an OpenCV GUI app, and that GUI app is going to have GUI, right? So there's going to be a while loop running there, and then maybe on a key press or a button press or something, I could start like a file IO process, either writing a big amount of data to a file or reading a big amount of data from a file, something that I know is going to take a couple of seconds to do. Right. So that would be a good example where I could probably have like a timer running, and I could display that timer through the UI on the screen. So that way I'll know when the thing is being read, if there's a if there's a pause, if the thing like freezes, then I'll know that it's actually blocking. But yeah, okay. I think the reason why the function is async is probably because we are awaiting from within this function. Like I don't think we would be able to await from. Let's try making a. Uh, let's try doing it from within this function, the test function. Right. So in here, let's do await async io dot sleep. So what is this saying? Await allowed only within async functions. Okay. So then that is the reason why we have await here. No, that is the reason why we have async here. It's because we have await here. Because we are awaiting functions within this function, that's why we have async. And likewise, because we are awaiting this function within this function, that's why we have async here. I don't remember what my first assumption was. I believe my first assumption was wrong, because my first assumption was kind of looking at it the wrong way. I think the way that I was looking at it was actually I think in my first assumption I was looking at it from the point of view that um, this function is async because I don't remember. Okay, whatever. It's fine. I get it. I get it now. Uh, okay, so I know how that's supposed to work. All right, so the next, oh, this is the third method. So we have method 1, method 2, and now this is method 3. The async io.create task function to run coroutines concurrently as async io tasks. Let's modify the above example. Okay, before that, let's create the thing. So let's say, I haven't read that whole thing, but I'm going to try and create the thing by myself. So say after. Okay, we can add the time here after and um, say, I guess. Okay, so what was the thing that I was doing here? We await first, right? So async io dot sleep. So that's after. And then we print out say. Oh God, what did I just do? Okay, yeah. We print out say. Right, great. So here, the only thing I would need to do is await say after hello, and then say after, actually here we could do to world, and then I don't think we need a return thing. And then here we just await. Oh, easy. Okay. Await main, and then when we run this, it's going to print hello and then wait for, oh, so it waited for 1 second and then printed hello. And then, oh, you know what? Just for the sake of knowing when the thing is starting. So we say starting main, and then ending main. All right. So we run this, we start. 1 second later, there's hello. And then 2 seconds later, there's world. And then it ends. Okay, cool. So we just recreated that example. Awesome. Okay, yeah, this function was also, or well, this example was also doing pretty much just that, more or less just that. It's their print statements were a little different, but like more or less it was just that. Great. Okay. Also, I never thought about using time to basically get the time exactly when they were being, when the functions were being called. Yeah, good to, that's something good to keep in mind for the future. Okay, let's modify the above example and run to say after coroutines concurrently. Run them concurrently. So this is where it goes into threading, doesn't it? Because then it's running them in parallel. No, hold on. Wait a second. So they say concurrently. Does concurrently mean, because concurrently generally doesn't concurrently mean it's running in parallel. It's running like two, it's running. No, hold on. Because okay, would concurrently mean that it's running on two separate threads, or is it running, are they both still running on the same thread, but somehow they're both still executing, which I'm not sure what would be going on there. Let me Google this. Async IO concurrent versus parallel. What's the difference between concurrency, parallelism, and asynchronous methods? Great. Oh, there's a bunch of text to read here. So, um, give me a second. Let me bring that up here. Concurrent versus parallel. All right, great. That brings that up. And now we can transition back. Okay. Um, con- oh, Concurrent and parallel are effectively the same principle, as you correctly summarized. Both are related to tasks being executed simultaneously, although I would say that parallel tasks should be truly should be truly multitasking, executed at the same time, whereas concurrent could mean that the tasks are sharing the execution thread while still appearing to be executing in parallel. Okay, that's interesting. Asynchronous methods aren't directly related to the previous two concepts. Asynchrony is used to present the impression of concurrent or parallel tasking, but effectively, an asynchronous method call is normally used for a process that needs to do work away from the concurrent application, and we don't want to wait and block our application awaiting the response. Yeah, okay, all right, cool, cool. Concurrency is when the execution of multiple tasks is interleaved instead of each task being executed sequentially one after another. Parallelism is when these tasks are actually being executed in parallel. Back up. Concurrency is okay. So is I guess my question is, does concurrency mean multi-threading or not? How to use so and so, how to articulate the difference between asynchronous and parallel programming. Um, is async IO parallel or concurrent? So async IO enables concurrency but not parallelism. The key is that it uses cooperative multitasking. Each coroutine yields control back to the event loop willingly. Wait, I still don't get it. Is it running on a different thread or no? I'm still confused about whether it's running on a different thread or not. So let me just keep. Okay, so that is about threading. That is about multiprocessing. This is concurrent dot futures, a modern interface to threading and multiprocessing. Then we have async IO. Also note that async IO can await functions executed in thread or process pools provided by the concurrent dot futures. So it can serve as a glue between all the different models. This is part of the reason why async IO is often used to build new library infrastructure. Okay, okay. Concurrent.futures, a modern interface to threading and multiprocessing. Is the music still going? Yeah. Um, a modern interface to threading and multiprocessing, which provides convenient thread slash process pools. It calls executors. The pool's main entry point is the submit method, which returns a handle that you can test for completion or wait for. Okay, I'm not sure. if I'm getting my answer here. Okay, let me try something else. Asyncio dot create task single or multiple threads. Okay, all right. Okay, you know what? I'll look into this later on. For now, let's just carry on with the example. So, the async io.create task function to create, no, to run coroutines concurrently as async io tasks. All right, okay. So if we have both of these running, if we have both of these running, it's not going to be it's not going to be that we wait for 1 second and then print out hello world, or print out hello and then wait for 2 seconds and then print out world. I'm guessing we are going to start waiting for hello, but at the same time we're going to start waiting for world as well, meaning hello is going to be printed 1 second later, and then 1 second after that, not 2 seconds after that, world is going to be printed. Wait until both tasks are completed should take around 2 seconds. Yeah, okay. So then it doesn't take 3 seconds. It takes 2 seconds, meaning I'm guessing it's running on multiple threads. I still have to look into whether it's actually running on a different thread, but it's good to know that this is possible. Let's modify this example. So we are starting main, and then we create task O1 equals async, what is it? Async io dot create task, I think. Isn't that it? Hold on. Yeah, it's create task. Within create task, we want to call a coroutine, which in our case is say after, and then we pass in our usual arguments. Then we create another task, which is say after 2 seconds. Then we have world, and then we are awaiting the tasks instead of awaiting. Actually, wait, let's erase this. So await task O1 and then task O2. Okay, so if I run this, it should run in 2 seconds, right? So we have that and that. Yeah. So I don't need to look at the timing because I know that that ran 1 second later. That ran 1 second after, or well, yeah, that ran 1 second after this ran, as opposed to if I were doing the other thing, which was await, say after, one, hello, and then say after, two, world. So if you look at the timing of this, what just happened? Oh God, what did I do? Yeah, let's run that. Let's run that again. So if you look at the timing of this, it's different from the timing of this. You see that? There's definitely a difference there. All right, so I'm going to dig into this later on to see whether it's actually running on different threads or if there's something else going on that's making it still somehow execute concurrently, even though it's running on the same thread. Like in case if it is actually running on the same thread, if there is something that is making it. Let me say that again. I'm going to do research later on to figure out if this is actually running on multiple threads or if it is running on the same thread. And if it is running on the same thread, then how exactly it is um, making it look like both of them are running concurrently, or how exactly it is making both of them run concurrently, even though it's on the same thread. Oh, okay, there's one more method. This is asyncio.taskGroup class, which provides a more modern alternative to create task. Using this API, the last example becomes async with so-and-so as so-and-so. We create this. Oh, that's interesting. Wait, what's the difference here, though? The timing and output should be the same as the previous thing. Okay. Wait, task group was added in 3.11. Do I even have 3.11? I don't know if I have 3.11. Or am I sitting on 3.10? So let's check. Oh no, okay. I have either 3.11 or 3.12. I'm talking about my Python version. Okay. So yeah, that's interesting that we can do it in that way. The await is implicit. Oh, I didn't even notice that. The await is implicit when the context manager exits. That's interesting, dude. So we don't have to call. All right, good to know. Good to know. All right, awaitables. We say that an object is an awaitable object if it can be used in an await expression. Many async IO APIs are designed to accept awaitables. There are three main types of awaitable objects: coroutines, tasks, and futures. Python coroutines are awaitable and therefore can be awaited from other coroutines. Okay, all right. Nothing happens if we just call nested. A coroutine object must be created but not. No, a coroutine object is created but not awaited, so it won't run at all. Okay, nested is a coroutine. Okay, all right. And then here we await. Let's do it differently and so on. So, okay. Important. In this documentation, the term coroutine can be used for. Give me a second. What's running right now? Okay, the music stopped. Okay, all right. Back to where were we? Here. In this documentation, the term coroutine can be used for two closely related concepts: a coroutine function, as an async def function, and a coroutine object, which is an object returned by calling a coroutine function. Okay, all right, so we looked at coroutines. Uh, what was this? Oh, the different types of awaitable objects. So the next type of awaitable object is a task. Tasks are used to schedule coroutines concurrently. When a coroutine is wrapped in a task with functions like so and so, the coroutine automatically no the coroutine is automatically scheduled to run soon. Okay, all right, that's fine, great, awesome. Then we have futures. A future is a special low-level awaitable object that represents an eventual result of an asynchronous operation. When a future object is awaited, it means that the coroutine will wait until the future is resolved in some other place. Future objects in async IO are needed to allow callback-based code to be used with async await. Normally there's no need to create future objects at the application level code. Future objects, sometimes exposed by libraries and some async IO APIs, can be awaited. Oh, sorry about that. Just hit my platform that I have my mic on. Okay, so await function that returns a future object. Okay, all right, cool, great. So this is going into creating tasks. All right, cool. So wrap the coroutine into a task and schedule its execution. Return the task object. If name is not none, it is set as the name of the task using task.setName. An optional keyword only context argument allows specifying a custom context for the coroutine to run in. Why are they calling this coro? Wrap the coroutine. Is that a typo, or does coro mean something here? Okay, either way. The current context copy is created when no context is provided. The task is executed in the loop returned by so-and-so, and runtime error is raised if there is no running loop in the current thread. Okay, asyncio.taskgroup.createTask is a new alternative leveraging structural concurrency. It allows for waiting for a group of related tasks with strong safety guarantees. Okay, important. Save a reference to the result of this function to avoid a task disappearing mid-execution. The event, wait, hold on, what? Save a reference to the result of this function. The result of what function? Create task? Oh yeah, okay, so the reference is in task. That's what we are doing. We're saving a reference. The event loop only keeps weak references to tasks. A task that isn't referenced elsewhere may get garbage collected at any time, even before it's done. For reliable fire and forget background tasks, gather them into a collection. Background tasks. Hold on, what is this? Just says background tasks equals set. Is there a function that I can call called set that just does nothing? What is, hold on. Set is a class, it's not a function. Okay, so we are calling the constructor of that class. A new empty set object. All right, so let's say bg underscore tasks equals set, and then we do, and then we do bg tasks dot add. So what does set create again? Creates a collection, build an unordered collection of unique elements. So that is why we're able to add stuff to it, because it's a collection. Okay. All right. For a second there, I was thinking there's some kind of like error over here. They're just calling some function set, but no, set is actually, it's a thing. Actually, I believe I've used set on a rare occasion in the past. Yeah, that was like one rare occasion where I had to use it for like a very specific purpose. Because like usually I don't need to call, I don't need to use that class, because quite often I'm using other collections, the regular Python collections, or whatever other library I'm using, that library's own collections I'm using. Okay, so we create this. Oh, so the idea with creating the set is so that we can store a reference to the task, and then we can add a callback. Hold on, this is interesting. So we can add a callback. Where exactly was it going to mention that we can add a callback? I don't think it mentioned anywhere that are callbacks mentioned somewhere else? Because like I noticed the callback thing here, and so that's basically like, okay, so we have the task here, and we can add a done callback, which is then going to call some function. By the way, real quick, we're just going to take a quick break because in 30 seconds there's going to be an ad break playing. There's going to be an ad break happening where an ad is playing. So I'm going to start the ad right now, and I'll see you guys in 30 seconds. All right, welcome back. So, yeah, back to this. So we can add a callback to a function, or we can add a callback to the task. The callback is called with a single argument, the future object. If the future is already done, when this is called, the callback is scheduled with call soon. Wait, that's kind of confusing. Okay, so I mean, I don't have to specify the type. I just have to create like an argument that's going to be used whenever this function is called, right? Oh, wait, no, I can't do that. How am I supposed to use this? It says, okay, background tasks dot discard. Let's take a look at the set example again. Let's do what bg bg fuck it bg whatever set, and then bg dot uh discard. Okay, um so we are passing in a function. We are not even passing in the arguments. We are just passing in the function as it is, right? Okay, so that being said, if I create something here, let's say I call it test O2, and let's give it this. So let's say callback called. Okay, so in here, task O1, we're going to pass in test O2. So now when I run this, after hello, our callback should be called. Okay, cool. There it is. So now we know how to add callbacks to tasks. How do we add callbacks to actually do we need a callback when it comes to like the regular coroutines? I don't think we do. Like we need it with the task, right? Because like if it's with a regular coroutine, I think we can just mention a function call in there, and then that can be our callback. Though I guess for more advanced tasks, because like I'm thinking about it with like a very simplistic example in mind, not something complex. Um, okay. The next thing is task cancellation. Hold on, I'm curious. What does so we have sleeping, we have task cancellation, task groups, sleeping, running tasks concurrently. This is something called gather. Run available objects in the AWS sequence concurrently. If any available in AWS is a coroutine, it is automatically scheduled as a task. If all availables are completed successfully, the result is an aggregate list of return values. The order of the results, the order of result values corresponds to the order of available in AWS. Okay, if return exceptions is false, the first raised exception is immediately propagated to the task that awaits on gather. Other awaitables in the AWS sequence won't be cancelled. Wait, the first raised exception is immediately propagated to the task that awaits on gather. Oh, so if there is an exception, it's gonna like what? It's just gonna cancel all of the others? Other awaitables in the sequence. Oh, okay. That directly answered my question. Okay, the immediate next sentence answered my question. Awaitables in the AWS sequence won't be canceled and will continue to run. Okay, how does that work though? Because like it's gonna return the exception. Once you have read from the thing, you're gonna read from it again. Like, how are you getting the results of everything else? Maybe I need to use this in an example in order to like get it, because I think I'm confusing myself. If return exceptions is true, exceptions are treated the same as successful results and aggregated in the result list. Oh, I feel like that would be a little more neat, because that way, once you get the results, then you can check if the thing was successful, then okay, great, do something with it. If it was unsuccessful, then you get the exception, so you'll know it was unsuccessful. If gather is cancelled, all submitted awaitables are also cancelled. Well, at least the ones that haven't completed yet. If any task or feature from the AWS sequence is cancelled, it is treated it is raised, as if it raised cancel error. All right, okay, moving on. Eager task factory, a task factory for eager task execution. When using this factory, coroutines begin execution synchronously during task. Okay, this seems like a more advanced thing. Maybe I should look into this later. Then we have shielding from cancellation. Protect an awaitable object. Oh, that's what AW stands for. Okay, now I get it. Because I was thinking about like AWS as in like I each time I read AWS, I think about the Amazon Web Service thing. Isn't that what AWS does? Isn't that what AWS stands for? Like with the Amazon thing, Amazon Web Services. Let me just Google that, because it's basically their cloud subscription thing. It's their cloud service. Let me just look that up. Yeah, it's called Amazon Web Services. Okay, cool, great. If AW is a coroutine, it is automatically scheduled as a task. Wait, so you can automatically schedule something as a task just by calling shield. So this scheduled task will then also be protected, so you can't cancel it? All right, okay, great. Oh shit, I hit the wrong key. Let's go back to that shielding. Okay. Then we have timeouts, return an asynchronous context manager. Okay, all right. Waiting primitives. Where is that? Run future and task instances in the AWS iterable concurrently and block until the conditions specified by, by return when. This is interesting. Returns two sets of tasks slash futures. Okay, how do you specify a condition? Are these the conditions? Oh yeah, these are the conditions. Okay. All right. Moving on. Running in threads. Asynchronously run function func in a separate thread. Run a core, return a coroutine that can be awaited to get the eventual result func. Okay. Um, scheduling from other threads. Okay. All right. Okay. Okay. All right. So this is the end of it then. So I'm probably not going to be looking into all of the sections in this page, on this page. Where was I? I think I was in task cancellation, right? Or was I in task groups? Because okay, I think I get the basic idea with tasks now and with async stuff. I think I'm kind of comfortable with it. What if we move on to this section, streams? I'll go over that coroutines thing again. I'll go over that page again, and I feel like at this point I'm gonna need to come back to this again and again, just for referencing it, or as the need for certain bits of information arises. I'll keep coming back to this page. Um, I don't think I need to finish reading the entire thing like right now, because I feel like I've gotten the information that I need. I hope I've gotten the information that I need, and as I need more later on, I'll come back and look at it. So we're going to start with the streams thing. Streams are high-level async await ready primitives to work with network connections. Streams allow sending and receiving data without using callbacks or low-level protocols and transports. Without using callbacks. You know what? Okay, it says without using callbacks. Now I just remembered, Python sockets had a non-blocking thing. Like what happens in a non-blocking socket? In the case of a non-blocking socket, okay, I'm Googling this on another system. So in the case of a non-blocking socket that has no data available, receive will throw the socket error exception, and the value of the exception will have the error number, so and so. Okay. The situation is a little different in the case when you've enabled non-blocking behavior via a timeout with socket.timeout or set blocking. In the case, dude, I need to no, hold on. We need to look into this because I'm curious now about Like, what exactly does non-blocking do then? If, you know, hold on. So we have socket here. Give that a second. Let that open up. Okay. Blocking. Non-blocking mode is supported through set blocking. A generalization of this based on timeouts is supported through set timeout. Okay. Set blocking or non-blocking mode. If flag is false, the socket is non-blocking, else it is blocking. Set a timeout on blocking socket operations. Now, see, what I'm trying to understand here is what is the point of making it non-blocking? Like if we are able to make it non-blocking and then give it like a callback method so that that callback method gets called when something is received, so that it basically becomes asynchronous at that point, right? I'm wondering, like, if we are not able to do that, what is the point of setting it to non-blocking? Like, what's the benefit there? Actually, let me Google that. What is the use of non-blocking? Wait, non-blocking sockets. Why should I use non-blocking or blocking sockets? Okay, that's a good. So that's not Python related. That is C++ related, but okay. Your question deserves a much longer discussion, but here's a short stab at an answer. Okay. Using blocking words, holy shit. Using blocking sockets means that only one socket may be active at any time in any one thread because it blocks while waiting for activity. Using blocking sockets is generally easier than non-blocking sockets. Asynchronous programming tends to be more complicated. You can create you could create one thread per socket as you stated, but threads have overhead and are extremely inefficient compared to non-blocking solutions. With non-blocking sockets, you could handle a much larger volume of wow, my mouth is just not mouthing, dude. Hold on. Let's try that again. With non-blocking sockets, you could handle a much larger volume of clients. It could scale to hundreds of thousands in a single process, but the code becomes a little more complicated. With non-blocking sockets on Windows, you have a couple of options: polling, events-based, overlapped I/O. Uh, all right. Uh, yeah, I'm still not getting it. Yeah, I'm still not entirely understanding what is the point of, like, what is I'm trying to imagine what would happen if we don't block. Like, okay, if it doesn't block, like let's say we create a socket, set it to non-blocking, and then we start a receiving operation on it, right? Now usually it would block the main thread if it was a blocking socket, but because we set it to non-blocking, like what happens at that point? Once we start the receive operation, it just moves on to something else? Does execution just continue? Because if it does continue, like how are we getting that data? Give me a second. So let's create a socket. Hold on, hold on. Oh God, what is going on? Okay, all right. So let's create a socket thing here. So let's do import, what is it? Sockets? Socket, I think. Socket, okay. And then, I don't know, let's do so1 equals socket dot socket. And here we specify, what was the constructor? I forgot. Or what was the list of arguments in the constructor? Give me a second. Let it tell us. Okay, there it is. So it is socket dot um, address family inet. So there's that. Then socket kind. Isn't this where we do datagram? I think. And then here we do I dude, I don't know. Okay. Whatever. So so1 dot, let's say receive. Not receive, receive from. Okay. Receive from returns a tuple. It returns a tuple and the return address. So now what I'm wondering is, let's say oh, hold on, wait, they mentioned this. So in that case, we would be using polling or event-based or overlapped I/O. Okay, all right. So if that is the case, does that mean there's a poll function? There's no poll function. Okay. Um, what other function would there be? Callback. Let's look for. Okay, the word callback is just not there. All right. How are we getting the data? Like, because like, okay, let's say this function returns a tuple, right? It returns a tuple, like it mentions here, which contains bytes and return address. Okay, so what exactly, how are we approaching this? Are we just constantly checking that tuple? Are we just constantly reading the value of that tuple? Or reading the value of the first element of that tuple? Because like, how do we know that the data is new? Like, how do we know that we've received new data? There's no callback specified here. Okay, maybe, you know what? Yeah, hold on. Maybe I should be Googling how to use non-blocking sockets in Python. How to use non-blocking sockets in Python. All right. So creating a non-blocking socket. What does this return? How to connect with a non-blocking socket. Socket.accept non-blocking. Non-blocking socket or asynchronous I/O? That's a very good question. So we're going to take a look at all of these questions. All right, so here I'm guessing they've set the, wait, that says 0. That's not true or false. Where is socket? Here. Okay. Set blocking is a flag, which is supposed to be, it's supposed to be true or false, but this is set to 0. Does it automatically convert that? Does it automatically convert 0 to false and 1 to true? Okay, either way. So it's set to non-blocking. I'm guessing that's what it means. It's set to non-blocking, and that is why. Wait, what is data here? Data equals connection dot receive. Oh, data is created right here. Then we have connection dot receive. Connection. Oh, this is a TCP thing, isn't it? Stream. Yeah, this is a TCP connection. Okay. All right. Then I tried to connect to the server from multiple instances of the client. What seems to be the problem there? But for some reason, putting blocking to 0 or 1 does not seem to have an effect on the server's receive. No, does not seem to have an effect, and server's receive method always blocks the execution. So does creating non-blocking socket. And so does creating non-blocking socket in Python require more than just setting the blocking flag to 0? Set blocking only affects the socket you use it on. So you have to add so and so to see an effect. Oh yeah, I just realized that. Holy shit. This is because like with the TCP, it returns a separate socket. It returns another socket which represents a connection to the socket on the other machine across the network. And well, no. It returns the socket that that represents that socket. It doesn't represent a connection to that socket. It represents that socket itself, at least from what I remember. And so that's why you're able to use con.receive. Now let's see if con.receive actually worked for this person. Set blocking does affect socket.accept, which will not block waiting so and so, but raise an exception. The documentation seems to be incomplete here. You are, of course, right. I've removed the comment from my answer, but there is an exception. What? Wait, so socket.accept, it makes the receiving socket or the socket that's representing the socket on the other machine, it makes that socket non-blocking as well? Okay, you just need to call socket set blocking 0 on the connected socket. Okay, okay. Right. So in terms of, dude, I need to experiment with this. I need to experiment with this more. I feel like I need to experiment with this more. Like just create a simple bare bones, well, two simple bare bones scripts, and in them I'm going to try using non-blocking sockets, because it just seems like, okay, if I'm imagining the workflow right here, because I don't know if I'm imagining it right, or well, I don't know if what I'm imagining is is accurate or not, but like if what I'm assuming here or imagining here is correct, the basic idea with a non-blocking socket is that you're constantly checking the buffer. You're constantly reading data from the buffer. Um, the only issue is that you don't have any way of knowing whether something has been received or not. Wait, does the blocking thing work for UDP or is it only a TCP thing? Because it doesn't specify any specific thing here. This method is a shorthand for set timeout calls. Um, socket dot set so and so is equivalent to this. Socket dot set so and so is equivalent to that. Okay. Wait, wait. This method is a shorthand for certain set timeout calls. Setting it to true is basically setting the timeout to none, and setting it to false is setting the timeout to 0. Okay, hold on. Let's read the remaining pages. So this was a page I'd opened on another machine, and this was the answer that I got here. Okay, let's try another thing. How to connect with a non-blocking socket. So this is also TCP because it's connecting and because that's stream. Okay, when using socket.connect with a non-blocking socket, it is somewhat expected to get a blocking IO error at first. See so-and-so for an explanation for the cause. Basically, the socket isn't ready yet and raises so-and-so. The solution is to either catch and ignore the exception or to use socket.connect_x instead of socket.connect because that method doesn't raise an exception. Especially note the last sentence from its description in the Python docs. Like connect, but returns an error indicator instead of raising an exception. This is useful to support, for example, asynchronous connects. Okay, all right. All right, let's take a look at the next one. Socket.accept non-blocking. All right. You probably want something like select.select. See the documentation. You supply select with 3 lists of sockets. With 3 lists of sockets you want to monitor for readability, writability, and error states. The server socket will be readable when a new client is waiting. The select function will block. Is select like its own separate thing? Okay, it's its own separate thing. So let's open that up here. This is a straightforward interface to the Unix select system call. The first 3 arguments are iterables of waitable objects. Okay, what is this library for? Waiting for IO completion. Oh, so this is where you have select and poll. This module provides access to the select and poll functions available in most operating systems, dev poll available in Solaris and derivatives, epoll available in Linux 2.5 plus, and KQ available in most on most BSD. Note that on Windows, it only works for sockets. On other operating systems, it also works for other file types. In particular, on Unix, it works on pipes. It cannot be used on regular files to determine whether a file has grown since it was last read. Okay, I guess that answers my question, right? So we use a non-blocking socket, and then we poll the socket. So I need to look at select and poll, both of them. Polling objects, there it is. The poll system call supported on most Unix systems provides better scalability for network servers that service many clients at the same time. Poll scales better because the system call can only no, because the system call only requires listing the file descriptors of interest, while select builds a bitmap, turns on bits for the FDs of interest, file descriptors of interest, and then afterwards the whole bitmap has to be linearly scanned again. Select is oh so and so, while poll is oh so and so. Okay. All right. Poll.register. Wait, this is talking about files. What about sockets? Okay, let's take a look. Okay, Python poll socket. Actually, I could search for the word socket here. Among the acceptable object types in the iterables are Python file objects, um, socket objects. Wait, back up. Are Python file objects okay, or socket objects. Okay, maybe they're just missing the word or there. Or socket objects returned by socket.socket. You may also define a wrapper class yourself as long as it has the appropriate file number method that really returns a file descriptor. File objects on Windows are not acceptable, but sockets are. On Windows, the underlying select function is provided by the winsock library and does not handle file descriptors that don't originate from winsock. I need to look at an example of how this is meant to be done. Okay, what are those for? Okay, all right. What is the purpose of polling? Okay, hold on. Let's read this anyways. What is the purpose of polling? Polling puts no put it into simple words. Polling frees CPU for other works when waiting for I/O. This is based on simple facts that CPU is way more faster than I/O, and waiting for I/O is a waste of time because for most of the time the CPU will be idle. Okay, all right. If you do read or receive, you're waiting for only one connection. If you have multiple connections, you will have to create multiple processes or threads, a waste of so and so. Okay. With select or poll or ePoll, you can monitor the connections. All right, great, awesome. Show me an example of it though. How to wait for any socket to have data. All right, okay. Select.select. While sockets, select.select. For so and so, do stuff, and then sockets.remove. Just don't forget to set the sockets non-blocking. The OP wants blocking since he removes the socket after doing stuff. True. I do want blocking. Okay. All right. Then why use select? If you want blocking, just do stuff on each side. That's true. That's what I was wondering. Like, if why are you polling it if you want to block anyways? If you do that, your sockets will be dealt with in a strict sequence. Using a selector, even with blocking sockets, allows you to react on any of the sockets becoming in readable state. Okay. Okay. So from the example, wait, socket.socket, p.register, p.register. Hold on, register. So polling register. Right. So I'm guessing FD can be like I can pass in. I think I can pass in. Um, yeah. I think I can pass in. Dude, should I spend now I need to think, should I spend time doing it this way or should I look into async async IO? Cuz like doing async IO stuff is going to be helpful for me, but I don't want to go too deep into it unless I absolutely need to. Cuz like I've learned about the coroutines, I've learned about the tasks, so I can do simple async stuff, right? And I'm wondering if that is going to be enough for me to be able to do async stuff using other async libraries, other libraries that support asynchronous programming. For example, if I wanted to use Twitch IO, which is a Twitch API library for Python. So if I wanted to use that, that does support asynchronous functions. So like if I wanted to do something with it, you know what? Let's take a look at Twitch IO real quick. Also, the music seems to have paused again, so let's just fix that. Okay, Twitch IO. Right, so let's open that up. All right, so it says fully asynchronous design. Right, so let's take a look at some example. All right, so here we create the class, okay? Then we have to create async functions. We have to specify these things. I need to look into what these things are. I think they're called annotations in Python. I don't remember. But yeah, okay. So that's like your basic. This is like your basic coroutine stuff. This is not even using tasks. This is just using basic async await syntax. It's not using anything super complicated when it comes to async stuff. Okay. All right. So I think I want to explore this. Dude, this polling thing seems like a very chaotic way of doing it, but I kind of want to try it. I kind of want to try it. I want to try exploring this chaotic way of, I mean, it may not necessarily be chaotic. It's let's say a more primitive way of doing it because there's probably better ways of doing it. One better way is the async IO way. However, async IO requires you to, at least for UDP, if you want to do UDP stuff, it requires you to go into this. So this is a page that I haven't looked at on stream, but I looked at it off stream. This page, it mentions stuff about UDP and other stuff as well. But I was looking for UDP specifically. So how you can use UDP. But like there's like I mentioned before, there seems to be, how do I say this? They've given you the API to build your own thing that you're then going to use. So there isn't like API available out of the box. You have to implement your own thing. At least that's what I've gotten from, the little bit of reading that I've done on it. It doesn't have like, simple methods like this, for example. Like this is assuming it's a TCP connection. So you have to connect and then accept and stuff like that. And then you can easily, read and write. And that's great because like it's simpler. You just connect the client and the server, and then you can do reading and writing very easily. But I kind of want to stick with UDP. Does it mention UDP anywhere here? No, nowhere on the page does it mention UDP. Okay, great. Though I'm still tempted to look into this at the very least. Even though I'm not doing too much TCP stuff, I'm doing mostly UDP stuff. At least, for my purpose, UDP seems to be working great. And a bunch of other things that I plan on doing also, uh, they kind of use UDP, or stuff that I'm implementing. I want to use UDP. I don't want to use TCP. So I think what I'll do is I'll explore this chaotic way of doing it. This is going to require me to sit down and like set up a simple server and client, just something that sends from one end and then receives on another end, and then the thing that received is then also going to send, and then the other thing is going to receive. So a server and a client, the server is going to send to the client will receive, then the client is going to send to the server, and the server will receive. I need to set up the mechanism on both ends, but I need to set it up with non-blocking sockets and make sure that I'm not actually blocking the entire thread. And the way that I can test to make sure I'm not blocking the thread is by using OpenCV, as in setting up like simple GUI, setting up a simple window, and I don't know, writing some stuff on the screen. If I'm still able to accept keyboard input, or I'm able to constantly change text, or other GUI or anything on the screen while it's waiting for something on the socket. If I'm still able to do it, then that means I lost my train of thought. If I'm still able to receive, no, if I'm still able to have functioning GUI, while waiting for data to be received on the socket, that means it's not blocking. And that means, however chaotic this method might be, or however primitive the method might be, uh, I should probably use it because it works well for my purpose. So what I could do is I could set up I could set up the polling to be, I don't know, every 1 second, and like especially for my purpose, uh, it can check, I don't know, every 5 seconds as well, because it's like, sending text data, right? Or it's sending individual messages is what I meant to say. It's sending like individual messages, so it's not going to be, though I don't think the polling operation is going to take too much away in terms of CPU time. So even if I was polling every 1 or 2 seconds, I don't think it's gonna eat up too much of my CPU resources. I'll look into that as well. Yeah, yeah. I think I'll look into that as well. Oh, finally. Hell yeah, dude. Okay, you know what? I don't think I've had a chance to raid Oz in a bit. So that's what we're gonna do. Okay? I'm gonna raid Little Witch Oz. Oz is cool people. Oz is a friend of the channel. We're gonna go hang out with Oz. Um, but yeah, dude, that's gonna be it for today's stream. I'm gonna carry on reading this stuff because I do need to implement this stuff later on. But yeah, Sarah, thanks for hanging out and chatting. Appreciate it. Anyone else who might have been lurking, thanks for hanging out. Appreciate it. I'll probably do another mute stream tomorrow. At the very least, I'm gonna be doing a mute stream, hopefully, because I'm trying to stream more and more. And if I'm able to, then I'll also do like one of my regular streams. But yeah, okay, okay. Enough rambling. I hope you guys have a nice day, and I will see you all next time. Peace.